So good morning all of you. In the last class, we have discussed about various mass storage systems. What is a compact disk? What are the secondary and tertiary storage mechanisms? And how operating system plays a role in controlling or in monitoring or synchronizing the external storage devices. Okay. So now we'll see what are the basic units of storage systems. Like you know that length is measured by meters, right? Standard unit is meter or centimeter, millimeter and so on, right? The same way, data has a basic unit of bits. 8 bits make a byte. We have kilobytes. 1 kilobyte is how many bytes? 1 kilobyte, 1 KB of data means how many bytes? Please refresh your school or your previous knowledge about how the information is measured. Information is measured using the unit of information is bits, bytes, or so on. Right? All what you are storing is units of information. That's it. So different units of information is being stored, and since it is two binary values, you have it as 2 to the power of everything, right? So 1 kilobyte is not 1000 bytes, but 1024 bytes. Similarly, you have all these kinds of bytes and storage mechanism. So how do an operating system manage this, or how do this operating system is going to store your information? There should be some unit, right? Something that is called as file. A collection of files is called as a directory, right? A folder. And a collection of folders and collection of so much material together is called as drive. Okay. So we'll see what is the concept of file in this session. We'll see what is file concept, what are the access methods, what is a directory, how directory information is organized, how file systems are mounted, sharing and interfaces, allocation methods, and so on. So what is meant by a file system interface? So what is a file system interface? I told you, you understand what the word interface means? Graphical user interface, command line interface. What is meant by graphical user interface? So a graphical user interface means an interface is something that connects the user to the system. Okay. So file system interface means an interface which is going to help you to create files, access files, delete files, and so on. Any system that is used to connect between the user and the machine is generally called as an interface. So file system interface is a bridge between the user applications and the stored data, providing a structured way to create, read, write, delete, and organize files. Access methods, we'll see what are the different access methods, how you are able to access the files, how you are able to use the files. Defines how data is retrieved or stored within files, influencing performance and usability. So what is meant by a file? So there are files. See, these are the files. Okay. the file management system FMS to the hardware, and you have these things organized. So whenever you want a file to be taken out, it will be done in such manner that the user will be able to transfer the required files, requirements to the file management system. File management system is a software that works within the operating system that is going to manage your files. Manage your files means retrieve the data from the hardware, give it to the user. Okay. So these are the files. Files can be of different types. Say a multimedia will be having an extension JPG, PNG, and so on. You will be having multimedia files, you will be having document files, you will be having source code files. Okay. So there will be different types. All file types will be organized in different fashion. There will be zip files and all those things. Zip file is a compressed form of set of files, right? So these are the different types of files we have video files, we have audio files, multimedia files, images, we have documents, we have source codes, Python, C, C++, and so on. We have Microsoft Word, docx files, and so on. So files can be of different types, and files are identified by what is called as extension. So we have a file called as x.docx. This indicates that this docx indicates that this is a Word file, and this can be operated, this can be accessed by the software Word, MS Word or something like that. Similarly, we have PNG files. Similarly, we have JPG files, JPEG or JPEJ, JPEJ, and so on. Okay. These are all called as the image files, the audio files, the video files are called as multimedia files. Okay. There are the different types of files we have. So whenever you have a file, a PNG file saved in your computer, when you click that and when you want to open that, what it should do, it should be able to access the correct location, the physical memory access location, right? So this is managed, and which is a correct software that is being used to open it. Say you're clicking a PDF, it should be opened by a particular file that is a PDF reader, right? So who is going to decide all these things, how it works? So all these things are managed by the operating system's file management system. So what are the basic operations that is being performed in a file management system? The fundamental operation in a file is to create a file. You can right click and create a Word document. You can open a Word document and say whether there are different ways of creating or deleting files. These are the basic file management operations. These are the things that is going to help you create files, open or close files. Once you have saved your files, it is being saved in a particular memory location. You need to access it. The next thing is that you need to edit it. You can read that and you can write it. Search for files. The very common operation, we need to search for particular files, right? So all these functions are provided in your operating system, where you can type the name of the file, you can type the type of the file, and so on, and search for all kinds of files. Metadata. What is metadata? When you right click the file, you can see that the storage space used, the name, the different properties of the files. Okay, these properties are called as metadata. The metadata is used as a header of the file. So this is the type of the file. These are the things that have to be done. Okay. 1 second. So next point is about directories. So we have seen what is a file, what are the operations that is being performed on a file, what are the important components in the file. What is meant by a directory? A directory is something that holds all these files together. Okay, you have a directory, you already have been using this in your everyday life. You can create a folder. What you call a folder is something similar to a directory. Inside the folder, what you do is you save all the files. So there is a directory. A directory consists of directories or files. Okay, this can be a file, this can be subdirectories, and the subdirectories can contain further subdirectories or files. Okay, and every directory can contain multiple types of files. So each entry in a directory refers to a subdirectory or a file. So its type, its organization, its location, its access mode, etc. So directory structure helps system map file names to its actual objects and track them when in use. Already open file, you are double clicking, you wanted to open it again. What it does, it is taking the instance from where it is already open and giving you, right? Yes or no? That means that there is a process that is happening behind the screen inside your operating system. That particular file, when you double click, it's already working now, so it's just opening the same thing. Am I right? So all these things needs to be have an entire control or a synchronization. That process is being done in file management system aspect of our operating systems. So this is a master directory and we call this to be a drive. There will be a C drive or D drive or something like that. This will have multiple folders or multiple files. Okay, and this will have subfolders and so on, subdirectories. Even you can have directory files also in that. So this is the basics of the directory system in Windows. The same thing in Unix is described here, the next diagram. Okay. So what are the basic directory operations? Create or delete a directory. When you create a directory, what you are doing is that you are allocating a memory space into the directory. You are giving some space for the directory to save its documents or save its files. Okay. Next is that whenever you click a directory, so in directory operations, the next one is that just now we have seen how the files are being listed. When you open a directory, you should know all the properties of the files to list the files. Okay. The next one is about path resolution. That means that directory structures. Where is the this thing? Location. Navigate directory structures. That means you enter into the home. You keep going inside and inside and so on. Another function, directory operation, it is metadata handling. I've told you what is metadata. I've shown you in live what is metadata. Okay. Storage attributes like the name of the file, the size of the file, who all can access it. An operating system will be in such a way that there will be multiple users. Okay. And we have seen what is that in the last modified access. So metadata can be accessed via system calls like in Linux we have start, get file info, in Windows and so on. So what are the different types of access methods? The name makes you very clear that access methods means how are the ways in which you can access every file. So there are three types. First one is called as the sequential access method, direct or random access method, and the third one is the indexed access methods. We have three types. First one is called as sequential access. Sequential means one after the other. Okay, you have one file, that file after the next one and so on. Okay, so like a tape model, one after the other, data in a file can happen only sequentially from beginning to end. This is one access method. Random access, there is no order. Wherever you want, whenever you want, you can directly access the part of the file wherever it is. Okay, this is called as direct or random access. You open a PDF file and you search for some document, you go to a particular page directly. This is called as direct access. Sequential access one by one. What comes first is shown first, what comes second is shown second, and so on. Third one is indexed access. That means that 1, 2, 3, 4, you have this index. You click this file is being accessed. This is a file name. The other one is like that, and so on. This is called as indexed access. That means you have an index file that is being sorted in some way or the other. Could be alphabetical or the other way around. So this type of access method is called as indexed access method. The next topic is file allocation methods. File allocation methods. File allocation methods define how file allocation methods define how disk blocks are assigned to files, impacting storage efficiency, access speed, and the third point, scalability. Three things file allocation methods means what file it is going to do, how disk is going to space or block the space for the assigned files. So this will affect 3 points. First one is storage, second one is access speed, and third one is scalability. There are three primary methods. There are three primary methods. First method, contiguous allocation. Second method, linked allocation. Third method, indexed allocation. So, in this slide, we are studying file allocation methods. There are three primary methods of allocation. What is that first one? Tell me. Contiguous allocation. Second one, linked in allocation. Third one, indexed allocation. What are the things that is going to be affected by file allocation methods? First one is that storage efficiency. Second one is access speed. Third one is scalability. Storage efficiency means at the other time fragmentation, how much you are able to effectively store. Access speed is the time that it takes to access this. Scalability means there might be very small files, there might be very large files. Right? All these things should have equal or proportionately equal ways of access. So what are the file allocation methods is clear for you? That we are supposed to deal with is about the next important topic that we are supposed to deal with is about free space management. Okay. So in this slide, we are studying what is free space management. File systems must efficiently track and allocate free disk blocks to store new files and data. Several techniques are used, each with trade-offs in speed, storage, overhead, and scalability. So what does this mean? You should know the amount of free space available in your disk so that you can create a new file. When a new file is deleted, you should put that free space into that space that was occupied previously by that file into the free space. And this free space management is another important characteristics or is another important function of our operating systems memory or storage management system. Okay. So what are the different methods through which we can manage the free space? First one is called as bit map or bit vector. Bitmap vector. A bitmap is used where a bit represents a disk block. See, now what we are doing is that we are studying about free space management allocation methods, right? How we are working out. 1 means it is the block is allocated, 0 means it is free. This is bitmap vector allocation methods. So what are the advantages? Point number 1, easily you can find out which is free. Low space overhead. Point number 3, works well with all kinds of disks. Actually, we have a lot of dynamic disks, static disks. There are so many types of storage devices, hardware devices. In reality, you can understand how these allocation methods work only if you are very familiar with the differences between different types of memory that is being used in your operating system. Okay. The disadvantage we have for this bitmap is that it is slow for large disks. As the memory space increases, naturally it is very difficult. Fragmentation risk if not optimized. The next is linked list free block chaining. The next free space management technique that we are using is linked list free block chaining. So this is like a chain rule, like a relay. You have seen relays, right? One person will be having this relay card. He'll run 100 meters for a 400-meter relay. What he does is that he hands over the relay to the next person and so on, right? The same way, each free block will have a connection to the next free block. Okay. Once this is used, what it will do? It will say that the next free block is available at that particular location. So that it saves a lot of time. Like linked list, you have used linked list in C programming, you could have understood this much better. So you have the address of the next location, free location in your system. So here there is no extra storage overhead. These are the advantages because it is very quick and very easy to implement, like the bitmap. It is very inefficient because very difficult to find out the exact spaces where the free storage is being used. Okay. As sequential scanning is used because it will take one after the another, it will keep checking which is free now. So it will take time. Slow allocation, sequential scanning is required. Okay. Next one, slightly modified LinkedIn. Okay. Slightly modified linked list. In one linked list, you have multiple free spaces that is being listed. Okay. So when compared to the first one, second one has more features. When compared to the second one, the third one. When compared to the first one is bit map or bit vector, which is going to identify by the bit that it has 0 or 1. It is going to identify. Second one is linked list. Linked list will store the free space next memory in its place. The third type is slightly modified called as grouping, where you have a group of free spaces in one memory location. It is much faster than the plain linked list because you don't need to have the second kind of sequential allocation. Okay, but not as fast as bitmaps. It reduces fragmentation. Counting or contiguous free blocks. What here we are doing is that we are searching for the set of free blocks available. Okay, instead of one by one, which is done in bitmap, here we are selecting the set of continuous individual free blocks. starting block address and end. Efficient for large contiguous blocks. Works well with sequential allocation. Inefficient for highly fragmented disks. We have so many fragmented disks, several here and there, one storage is there, it's very difficult. It is very useful for contiguous allocation. Contiguous means one after the another. We have it continuously allocated. Next, advanced indexing or B tree. Here we are using something called as B tree or B plus tree to index free blocks. So this is a type of indexing, allows logarithmic time searches for free space. The advantages of B tree is that it is much faster for large disks, more balanced and scalable. Scalable means you have a larger. See, we are not going to see in depth about what is B tree algorithm because it is beyond the scope of our study. We just need to understand that you have an algorithm called as B tree, which is going to help us index the free blocks. It is like you know the statement, but you don't need to study the derivation. You don't need to study the algorithm. That's bit time consuming and not required for you. Input output systems in OS management. So in your computer, you have keyboards, monitors, printers, printers, keyboards, etc. So one part of our system, operating system, is used to manage this input output devices such as keyboards, printers, scanners, monitors, webcams, etc. In simple terms, we have put it as disks, keyboards, network interfaces, and so on. Okay. So there is an IO subsystem in your operating system kernel. Okay. That IO subsystems has these following functions. Input output scheduling. That means that if there is an output device, which process has to first access this output device. Okay, this is called as scheduling. Scheduling means which has to come first. This we have been seeing from the beginning of our subject. This means that everything has its own time and only on its time it is allocated to utilize that particular system. Is that clear? Buffering means there should be a space, in the queue to stand one after the other. So that process is called as buffering. So the process that is there in the next will be buffered and will be having a particular space to stand on. Caching. Some things are very frequently used again and again and again. Okay, so this should be in a very accessible point of view, right? That is called as caching. Simultaneous peripheral operations online, that means it's called as pooling. I'll teach you that in depth in later sessions actually. Second, the next one is error handling and device reservation. Error handling means you have some kind of problems, errors that has occurred within the output system. It has to be handled, right? Device reservation. There should be priorities, right? Something that is first should be done first. Something that requires to be done last, that has to be done last. This process. So these are the important functions of operating systems IO subsystem. Is that clear? All of you understood? Purida. So with this, what I have done is that I have drawn a skeleton of what is there in your fourth module. So with this, we are winding up our fourth module. Is there any questions to ask? You're always free to ask me questions. So thank you all.